So, ladies and gentlemen, my name is Pavel Skoda, and I'm happy to be here in Africa with you. It's very nice here, and I'm representing non-profit organization CesNet, which is operating national research and education network in Czech Republic. What I want to tell you today is about innovative photonic devices that help us develop our network and help us also to introduce some network optimization that you may not be aware of, and also to introduce some new services for NRENS. So I will start with a short outline. Here, first of all, I will have just a couple of words about CesNet as a Czech Research and Education Network. Then I will have a couple of words about NREN's purpose, as I see it quite important. And then I will get straight to the optical core network optimization, where we found three major ways that I would like to uncover today. And then I will talk about innovative photonic network devices that help us to achieve this optimization. And just right to add, I will just mention some new network applications and conclude my talk. So I don't want to bother you much with geography, but just to compare it a bit, the Czech Republic is 7 times more than the Republic of Kenya, and roughly 3 times lower populated than the Republic of Kenya. So I believe that our NRENs may have kind of similar issues or similar starting conditions, since we are a little smaller, but we are in Europe. Well, so about CesNet as the association of legal entities, we employ 250 researchers and staff, and are focused mainly on optical core network development and operation. Then we have also part of the team working on programmable. Then we are also have part of the teams working on programmable hardware, network security, and special network applications. Today we connect over 40 partners, and we have mainly universities, hospitals, and research institutions. Our network spans today roughly 5,000 kilometers. It is all optical network with DWDM technology. And the majority of our network has today employed the innovative photonic network devices. So it was just a quick summary. And now I would like to get to the purpose of NRENS, because I see it as important thing, because as it was mentioned already here, NREN has to differ from ISPs and telco providers to have some added value. So I see that the support of research and education partners, which are partners to NRENS, is the most important thing, and the delivery of network services to them is really important. Well, every NREN usually starts with connectivity and then can improve it with some more applications. But the connectivity is mainly the most important issue, as NREN is helping to minimize the distance and digital divide by forming some kind of development project or so on. In our country we do this through the development projects, so maybe it would be also possible in your country, or maybe handful. Well, also one really important thing is that providing partners with collaborative and educational environment is really important through the video conferencing or the connection between them for collaboration. And also I think it is important for NREN to have some research in networking that comes usually later on, after some development, but it helps NREN to deliver the the most recent technology to research and education community, and therefore improve their work considerably. Regarding the funding, I just want to mention the scheme that we have in our country. We usually have some cost share from partners, from universities and so on. And then we get some more funding from state projects, research projects, and also technology transfer as an outcome from our research. So for the optimization, I tried to make a simple scheme just to show a simple, really simple idea. Well, as everybody knows, for internet access, there are, let's say, major players in game. There are telecommunication providers and internet service providers. They all pursue capacity, bandwidth, also the area coverage and number of end users. It's obvious it's part of their job. And there are big vendors of networking equipment, mainly the optical one, that are, designing their systems right for the biggest players in a game. So, besides that, there are national research and education networks that may have some other, let's say, targets or goals first. And one of them is for sure the connectivity to partner. It is usually more important to get to your partners to overcome the last mile than to have the large capacity and bandwidth on that link. Another one is the flexibility of your network, that you can respond to any request from research and education community. And the last point I have here is international connectivity. That means also the interconnecting of NRENS together. So besides looking at these points, I feel that there is cost-effective network building that would be rather right to these parameters, and there is also place for flexible network devices. So as a first approach to be identified as a key one of the first ways. We call customer empowered fiber network. What we want is optical network flexibility. So it means freedom in fiber lighting and technology selection. And beside that, also flexibility to network capacity and technology change and quick adaptability to new technologies. So the answer for this is dark fiber infrastructure. Well, the dark fiber means that you have the control of the very optical fiber. That could be done, let's say, in several ways. You can deploy a fiber plant, or you can, for example, as it is common in Europe, you can rent a fiber from a company that is, owning the fibers. And in this way, you will get complete control over the resource, the optical fiber, the physical layer. And then you can deploy there any lighting technology which you will need, or that it will be suitable for your conditions. And it's also easily accessible for research purposes, and it's a perfect resource for innovation and the education of experts. So a good thing on the fiber rental, as we see it, is that the technical support is provided by the owner of the cable, of the optical link. So the NREN don't have to employ that many people for technical support. Well, but maybe in Africa the deployment may be also the option because of the different pricing here and in Europe. It's beyond my knowledge anyway. So the next way for optimization we see in approach we call nothing in line. As most of the engineers know, when you are designing the optical link, let's say the core network link, there are endpoints and then fiber spans of length about 80 to 100 kilometers, and then some housings on the way that house devices for amplification and so on. but well, 100 kilometers is not the that long distance. So we thought that by modifying the endpoints, the hardware there, we may overcome that distance in one hop. So for this, we started to do our innovative photonic devices. And we actually did devices that can overcome more than 200 kilometers, giving you savings in CAPEX and OPEX for, let's say, 1 or 2 intermediate housings. And such housing, it's not just the rental cost, but you also have to solve electricity access, the security, and also buy more devices to house inside the housing. So here is the example of one of our lines in our country. It is overcoming 224 kilometers and 50 decibels of attenuation. And this is thanks to those innovative devices that we developed exactly for this purpose, and that really helps us save a lot of money. So the third way, which we find interesting, is single fiber bidirectional transmission. The thing which, that scheme I have here is really simple. It's just for demonstrating the idea. So, well, once we had the nil approach mastered, then we said, okay, there is a lot of bandwidth on that link that we may never use. So why we couldn't just rent a single fiber and modify the hardware to make the transmission possible? Well, we have done some work on that, and it's actually possible, and saved us a rental cost of about 40% of rental cost for the fiber pair, which is well, it's for Central Europe, but it's not a bad deal. And the cost is just a little higher device complexity, but the bandwidth is half, as I explained. So when I turn it into numbers as a quite very simple computation, you will end up with 400 gigabits per second per each direction, which is usually more than enough for any NREN with a standard 10 gigabits per second technology, which you can get today quite easily. So from this, we also think that it's optimized for emerging networks, because there would happen that you would run out of capacity. You can simply rent another fiber or get another one and have a fiber pair. So this all was done thanks to our, let's say, innovation photonic network devices. Well, I have to say that all these devices, the pictures here are not because I want to sell it to you. It's just that you see that it really exists. It's not a legend or something like that. But all those devices were developed based on our needs. So it were not planned, but we gradually find out that we need more and more from the network, and we modified hardware to do it. Well, so today our family of optical network devices is a full set of devices for core optical networks. They allow to adapt the core network optimization, as I was talking about, and they are, well, this is the quite important thing, they are open to modifications. As we are a non-profit company, we can't have like closed devices, we are not producers, so we have to keep our findings and our research open for all, which is quite interesting for other NRENs, because they can, learn from our findings and even then modify our devices for their purposes and for their use. And these devices are also optimal for staff training and education. And so far, we are doing the technology transfer through licensing. So we have 2 companies in our country that are able to produce such devices, and they can deliver it to anyone interested. And we are only taking just a small fee for a license, because, as I said, we are a non-profit company, so we can't have a big profit anyway. So at the end, I would like to just highlight some applications which we have done over recent years. And I feel that in general, the important part of NRENS output is or are those applications. They differ us from the ISPs. And what I think it's very interesting is that those applications are area or region specific. So as I expected, as NRENS in Africa will develop to have some kind of research, they will find new applications and they can differ even more from ISPs later on. So just to mention a few, I can mention the broadcast of real-time 3D high-definition video, which we have done over our optical core network for transfer of video from robotic operation to a class of the students at medical university. But it's not that big deal, but we tried to do it in real time, so they could communicate together, and actually the students could ask questions to surgeons and talk with them. So from technical point of view, we overcame 150 kilometers with delay less than 1 millisecond, and the data flow was around 2.5 gigabits per second because of uncompressed formats that we have there to attain as much as real-time feeling for the end users. So the next two are a bit maybe weird for you, as they are really research dependent. And the first one is atomic clock comparison. That's well, atomic clocks are the devices that are keeping the time etalon in the regions. And so far, the comparison of such atomic clocks has been done over satellite links, but we made it over the orbital networks with some maybe a little improved stability. And the main point on this is that we require all optical path between the institutions, so it's not always that easy to do that, and it's not possible over ISPs at all. Well, the last one is the ultra-stable frequency transfer, which is used for meteorology, astrology, and particle physics, and it has been done in France, in Renater, it's another NREN, and it also went over 500 kilometers. This NREN also modified some devices and made new devices for the use. Well, yeah, I would like just to conclude it. Well, I think that NREN should have different goals than ISPs and telcos operators, it's obvious, not to compete with them, but to add some value for research and education community. Then NREN network can be optimized cost-effectively using the 3 ways or 3 approaches, or at least the 3, as we find them out. The customer empowered fiber network, nothing in line, and single fiber bidirectional transmission. Well, and we find open devices as a good candidates for NRENs because they allow quick adaptability to new requests and new parameters that one can put on them. And in the end, we find that optimized networks allows new applications because you can simply adjust your equipment to do whatever you want. In the end, I would like to acknowledge my colleagues from our group for great work they are doing. I'm obviously not the only one who is working on that. And I thank you for your attention. Thank you very much.